like I said, these calculations are difficult. You want to make sure to figure out how to use these exponent values in your calculator. Some of you who have been using them in calculus, or we definitely use them in chemistry, which might have been a while ago, but we'll talk about that also. But if you need help, come and see me after class, and I can try to figure out with your calculator how it's easiest to do this. But basically, you're trying to solve for frequency. You've got a velocity and you've got a wavelength. You're going to divide the wavelength over and plug it into your calculator. So you get 6.67 times 10 to the 14 hertz. Any questions? Again, if you did that process, which was just dividing the 4.5 to both sides, -7, then, and you got the wrong answer, then come and see me, and I'll help you figure out how to plug those values in. The next one was to take how long it takes for that wave to travel around the Earth. And for this equation, you have to do a little manipulation. So let me use a different marker. We've got velocity equals distance over time. And if you're solving for time, you need to figure out how to get that time out of the denominator, which involves multiplying the time to the other side to cancel these out, and then dividing the velocity to the other side. So you would end up with time equals velocity over, distance over velocity. Does that make sense? And then from there, you take your 40 million divided by 300 million, and you get a really fast, really quick light speed, or a really quick time, which is 0.13 seconds. To travel all the way around the world, it's in an instant. You can't really perceive the fact that light waves are actually traveling because it happens so fast. Any questions? Okay. What's the next one? It says, is it correct to say that in every case, without exception, any radio wave travels faster than any sound wave? So, did you learn about radio waves in the videos that you watched for homework? Was that included a little bit? Radio waves are part of what we call the electromagnetic spectrum. So they move at the same speed of light. So is it safe to say that that's going to move faster than a sound wave? Does light travel faster than sound wave? For sure. Radio waves don't seem like they're light waves, but they're part of that spectrum of electromagnetic waves, which is what light waves are. Are there any questions on this?